This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is sorbitol? Answer: sorbitol is an alcohol counterpart of glucose that is produced by the body through aldose reductase. Question: what happens to glucose when it is converted to sorbitol? Answer: when glucose is converted to sorbitol, it is trapped inside the cell. Question: how is sorbitol converted to fructose? Answer: sorbitol is converted to fructose in some tissues using sorbitol dehydrogenase. Question: what happens if tissues have an insufficient amount of sorbitol dehydrogenase? Answer: tissues with an insufficient amount or activity of sorbitol dehydrogenase are at risk of intracellular sorbitol accumulation, which can cause osmotic damage. Question: what happens when there is high blood levels of galactose? Answer: high blood levels of galactose result in its conversion to the osmotically active galactitol through aldose reductase. Question: which organs have both aldose reductase and sorbitol dehydrogenase? Answer: liver, ovaries, and seminal vesicles have both aldose reductase and sorbitol dehydrogenase. Question: what is the function of NADPH and NAD+ in the conversion process? Answer: NADPH and NAD+ are involved in the conversion process of glucose to sorbitol. Question: what are the consequences of intracellular sorbitol accumulation? Answer: intracellular sorbitol accumulation can cause osmotic damage, such as cataracts, retinopathy, and peripheral neuropathy, which are often seen with chronic hyperglycemia and diabetes. Question: which tissues have only aldose reductase? Answer: the lens primarily has aldose reductase, while the retina, kidneys, and Schwann cells have only aldose reductase. Question: what is the role of aldose reductase in the conversion of glucose to sorbitol? Answer: aldose reductase plays a key role in converting glucose to its alcohol counterpart, sorbitol. Question: what is the significance of high levels of sorbitol in the cells? Answer: high levels of sorbitol in the cells can lead to osmotic damage due to its accumulation, especially in tissues with insufficient activity of sorbitol dehydrogenase. Question: what are the tissues at risk of osmotic damage due to intracellular sorbitol accumulation? Answer: tissues with an insufficient amount or activity of sorbitol dehydrogenase are at risk of intracellular sorbitol accumulation and osmotic damage. Question: how does the conversion of galactose to galactitol occur? Answer: galactose is converted to galactitol through aldose reductase when there are high levels of galactose in the blood. Question: can the liver, ovaries, and seminal vesicles lose sorbitol? Answer: yes, the liver, ovaries, and seminal vesicles have both aldose reductase and sorbitol dehydrogenase, which allows them to lose sorbitol. Question: what is the role of NADPH and NAD+ in the process of glucose conversion to sorbitol? Answer: NADPH and NAD+ are involved in the process of glucose conversion to sorbitol and play a key role in this process. Question: what are the consequences of high blood levels of galactose? Answer: high blood levels of galactose result in its conversion to the osmotically active galactitol through aldose reductase, which can cause osmotic damage. Question: are the lens, retina, kidneys, and Schwann cells at risk of osmotic damage? Answer: yes, the lens, retina, kidneys, and Schwann cells are at risk of osmotic damage due to intracellular sorbitol accumulation if they have insufficient activity of sorbitol dehydrogenase. Question: why is aldose reductase important in the conversion of glucose to sorbitol? Answer: aldose reductase is important in the conversion of glucose to sorbitol because it plays a key role in trapping glucose inside the cell. Question: what happens if there is an insufficient amount of sorbitol dehydrogenase in the tissues? Answer: if there is an insufficient amount of sorbitol dehydrogenase in the tissues, it leads to intracellular sorbitol accumulation and a risk of osmotic damage. Question: can galactose lead to osmotic damage? Answer: yes, high blood levels of galactose can lead to osmotic damage due to its conversion to the osmotically active galactitol through aldose reductase. Question: what is the difference between tissues with only aldose reductase and those with both aldose reductase and sorbitol dehydrogenase? Answer: tissues with only aldose reductase, such as the lens, retina, kidneys, and Schwann cells, are at risk of intracellular sorbitol accumulation and osmotic damage, while tissues with both aldose reductase and sorbitol dehydrogenase, such as the liver, ovaries, and seminal vesicles, are able to lose sorbitol.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the first aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.